This is part 1 of your Prove It notes. Remember, your goal here is not to memorize, but rather to be able to understand and derive all of these formulas on your own. So let's begin here with our basic definitions. So I'm going to draw a circle. It's going to be a little mini unit circle here. And let's just draw any angle in here, theta, and call that point here P. And coordinates here, of course, are x, y. Okay. Now we have some very basic definitions. The cosine of theta is equal to our x value, right? This is the x coordinate here. The sine of theta is equal to y. The tangent of theta, which is the ratio of sine over cosine, would then equal y over x. Now for your reciprocal functions, and again we're just defining these, the secant of theta is 1 over cosine of theta, which means it's 1 over x. The cosecant of theta is 1 over the sine of theta, the reciprocal of sine of theta, and we end up with 1 over y. The cotangent function is the reciprocal of the tangent function, which means that it's cosine of theta over sine of theta, or x over y. So this is the basic definitions, which is going to help us then in deriving all of the other identities and formulas that you're going to be using throughout this Prove It Notes section. Working on section 2 of our Prove It Notes, we're going to look at our Pythagorean identities. Now, what we're going to start with is the equation of our unit circle, x squared plus y squared equals 1. The reason why this is in a subheading of Pythagorean identities is because if we look back at our diagram, when we did our basic definitions, if we take a look at this and I create a little triangle here, a little right triangle, remember my unit circle here has a radius of 1. This length here is my x value, and this length here gives me my y value for p. So if I just use Pythagorean theorem here, x squared plus y squared should equal 1. Okay, so it's both our equation for our unit circle as well as just an application of the Pythagorean theorem. So now I'm going to use, again, our definitions here to substitute values in for x and for y. Now, x is the same as cosine theta, right? So if I substitute here, I now have cosine squared theta plus sine squared theta equaling 1. I'm just substituting again. X is cosine, y is sine, rewriting that as cosine squared plus sine squared equals 1. So this is my first Pythagorean identity. Now, to derive others, I'm going to continue using cosine squared plus sine squared equal to 1. I'm going to use this identity here and manipulate it a little bit. First, I'm going to take everything and divide by cosine squared. So I'm dividing both sides of my equation by cosine squared. Now, cosine squared over cosine squared obviously is going to simplify to just 1. And sine squared over cosine squared, this is really tangent squared. Okay, so I have tangent squared theta equaling 1 over the cosine squared theta is actually secant squared theta. Right? It's the reciprocal of secant squared theta. All right. This is my second identity then. For my third identity, again, I'm going to take cosine squared theta plus sine squared theta equals 1. It's a true statement, right? That means I can manipulate this equation just like I did the last one here using sound, algebraic operations. So in this case, I'm going to divide everything by sine squared theta. So I'm taking both sides of this equation here, dividing by sine squared theta, and I'm just showing it under each one so that you can easily see how this is going to then manipulate a little bit. And cosine squared theta over sine squared theta, well, that's just cotangent squared theta, right? Sine squared theta over sine squared theta is simply 1, so I have cotangent squared theta plus 1 equal to 1 over sine squared theta is just cosecant squared theta, okay? And this gives me my third Pythagorean identity. So that's section 2 for Pythagorean identities. Again, you're just starting with either your unit circle, think of it that way, the equation for that unit circle, substituting in values, or think of it as Pythagorean theorem as well. Substitute your values for cosine and sine, and then from here you're going to manipulate by dividing by cosine squared theta or sine squared theta. Okay?